Hello everyone. So we have this integral that you're looking at, the integral of 1 over square root of x times 1 minus x, and we want to integrate this. Now this is the kind of integral that you typically run into in a second semester calculus, so we cannot really use a substitution method to do this as you did in your, say, Calc 1 method. So let's see how we're going to do this. I mean, we're still going to use a substitution. It's just the result is not the result that you would see in the first semester calculus. So I'm going to call this first method, let's call it method 1. In method 1, I'm going to rewrite the denominator of the fraction, the radical mainly. The focus is on the radical here. So I'm going to rewrite it as, first I'm going to break it off into two radicals. Then I'm going to rewrite the 1 minus x. The x itself, I'm going to write it as the square root of x squared. Okay. And then I'm thinking of a u substitution. U would be square root of x. And the derivative of that, you can verify it. It's going to be 1 over 2 root x dx. Okay, so let's rewrite the integrand. The integrand is going to be that of 2. And then let me put dx here. I'm going to also write it over the denominator that I just made up. It's 1 minus square root of x squared. And then remember, we have a square root of x, so I have 1 over. I'm going to put 2 square root of x and dx, and you can clearly see why I'm doing that. So I'm going to make it look like this. So that means, let me erase the dx up here. And because we are multiplying by 2, that's why I have to also divide it by 2. Okay, and let me put this back on there. Okay. Alright, so what are we going to do next? The next step is actually use our u substitution to rewrite this integrand. And once we do, we pretty much have that answer. So the integral is going to be that of 2. I brought the 2 in the numerator out and write this as a du over the square root of 1 minus u squared. And then this is one of the integrals that we recognize as the arc sine of u. So there you go. That would be the answer. And of course we want to write it back in terms of the original variable of the integration, which is x. So that's simply going to be 2 arc sine of square root of x plus a constant of integration. Okay, so that's one way, pretty easy way to do this. Now of course, anytime the answer to a integral is going to be in trig form, chances are there's going to be various forms of the answer, so the answer may not in terms of trig form be unique. Usually the algebraic forms are unique, but the trig form, because of the trig identities, can be different. So let me actually rewrite what I have just above method 1, what I have written. This would be, instead of bringing the 2 out from the numerator, I factored or brought out a negative 2. So that means I need to have a negative in the denominator to offset. And this one, we recognize it as now the antiderivative of arc cosine. So that's going to be negative 2, this time cosine inverse of square root of x, or arc cosine of square root of x. Okay, so that would be the second method. Now the third method, which is also done, could be done, is actually going to give us a different answer in terms of trig function, but it works. For this one, I'm going to do what we typically do in, again, like a second semester calculus, in that I'm going to first factor the negative, write this as x squared minus x, and then complete the square in x. Now if you recall, completing the square in x requires that whatever the coefficient on x is, we need to choose half of that and then we square it. So if I take half of negative 1 and square it, that's simply going to be 1/4. So this is what I'm going to add, 1/4. And because I don't want to change the expression, remember the negative on the outside distributes to 1/4, so it's really negative 1/4 that was just added to the expression. So I'm just going to turn around and add 1/4 on the same side, so we haven't changed the original problem. Okay, and with this we can actually rewrite now what we have in the parentheses is what we call a perfect square trinomial. And what that means is that I can write it or rewrite it as a square of a binomial, and that would be the binomial. Okay, so there we have this one. And excuse me. Next, I'm going to work with this expression. So I'm going to actually expand the binomial, not expand it, but work inside the binomial. I'm going to combine these terms, and then let's see, let me put 1/4 in front, and then I'm going to have negative within parentheses. I'm going to write it as 2x minus 1 squared over 4. So what happened there is I choose the LCD, and then I squared the binomial. Okay, and once I do that, then I can factor the 1/4 outside. Okay, and then the expression is going to be 1 minus parentheses 2x minus 1 squared. Okay, so this is going to be what we're going to write in the integrand as. So let's go to our integrand. Our integrand, if you recall, it was 1 over square root of x times 1 minus x, and then dx, right? So I can write it as 1 over everything that you see here, the square root of, here's my integral symbol. It's going to be 1/4 of 1 minus 2x minus 1's quantity squared. Okay, I'm just going to put dx in the numerator here. Okay, good. And once we have that, now I can actually take the square root of 1/4 on the outside. So it's going to be 1 over 1/2. Okay, and then this is simply going to be dx over the square root of 1 minus parentheses 2x minus 1 quantity squared. Okay, and then I can make my u substitution. U is going to be 2x minus 1, so that du is 2 dx. Okay, and we're good to go. Now 1 over 1/2, invert and multiply, you get 2. And if du is 2 dx, divide both sides by 2, you get 1/2 du is dx. That's what's going to replace dx. So here's the 1/2, and this is going to be the du over the square root of 1 minus u squared. And then from this, again, once we cross out that 2.5, we recognize that as the antiderivative of the arc sine. This time it's going to be the arc sine of 2x minus 1. Okay, and plus a constant. So there you go. This time the argument of the arc sine, notice it's not square root of x. Our previous answer had square root of x. And going through similar steps, if you multiply the integrand top bottom by negative, the answer would also be written as negative arc cosine of 2x minus 1, if that's what you want, or if that's what you see. So there we got several ways of working this integral, and that's what we wanted to do. So hopefully you follow the steps, and again, it's not difficult to follow, but I just want to show you how that integral is evaluated.